Hi, this is Introductory Econometrics class, Lecture 2. Topic, Methodology of Econometrics. My name is Yusuf Ashir. So, the reference for this lecture is Gujarati 2004 Basic Econometrics, 4th edition. Let's go. Methodology of Econometrics. How do econometricians proceed in their analysis of an economic problem? That is, when econometricians want to analyze economic relationship, what are the steps they follow? Broadly speaking, traditional econometric methodology proceeds along the following lines. So these are the steps followed by traditional econometric in analyzing economic relationship. One, the first step is statement of the theory or hypothesis. Step 2, specification of the mathematical model of the theory. That is, the statement in the first step will be transformed into mathematical model. We are going to see this later in the class. Step 3, specification of statistical or what is also called econometric model. Step 4, obtaining the data. Step 4 is to obtain the data. Step 5, estimation of the parameters of the econometric model. Step 6, hypothesis testing. Step 7, forecasting or what is called prediction. Step 8, which is the final step, using the model for control or policy purposes. So we are going to take each of these steps one after the other. Let's start with step 1, statements of theory of hypothesis. Stating the theory or hypothesis to be tested is the first step in econometric research. Example of this theory, Keynesian consumption theory. So what does it say? There is a positive relationship between consumption and income. That's an hypothesis. Now, does this theory hold in reality? Researchers may be interested in empirical verification of this theory. Second step, after that, the second step, if a researcher is interested in empirical verification of the theory, so after stating the hypothesis, the next step is to specify the mathematical model of the theory. Then the next step is to transform that theory into mathematical form. Keynes did not specify the precise form of the functional relationship between consumption and income in his propounded theory. But for simplicity, a mathematical economist might suggest the following form of the Keynesian consumption function. Y is equal to beta 1 plus beta 2x, where beta 2 lies between 0 and 1, where Y is equal to some consumption expenditure, X is equal to income, B1 and B2, that's B's, known as the parameters of the model. B1 is the intercept, while B2 is the slope coefficient. The slope coefficient measures the MPC, that is marginal propensity to consume. Next, which is the third step, is to specify the econometric model of the consumption. That is, we need to make an amendment to mathematical model in order to transform it into an econometric model. A mathematical model assumes an exact or deterministic relationship between variables. Such a model is of limited interest to the econometrician. For example, in addition to income, other variables affect consumption expenditure, not only income. To allow for the inexact relationship between economic variables, the econometrician will modify the deterministic consumption function, which is stated above, Now, here is the multiplication. Y is equal to beta 1 plus beta 2x plus u. So we will see that under mathematical specification, we didn't have u. But the modification is the introduction of that u plus u. That u has turned a mathematical specification into an econometric specification. What does u mean? Where u known as the disturbance or error terms is a random stochastic variable. The disturbance term u may well represent all those factors that affect consumption, but are not taken into account explicitly in the model. You can see that in the model, we only have y, which is consumption equals to beta 1, which is the intercept, plus beta 2, which is the slope. We only have one independent variable, which is x, which is income. But other things apart from income affect consumption. So U captures all other factors that could affect consumption. The above model is an example of an econometric model. More technically, is an example of a linear regression model, specifically a simple linear regression model. The next step, which is step 4, is to obtain data. We need data in order to estimate the parameters in the specified model, the parameters beta 1 and beta 2. We need data on consumption and income in order to estimate these parameters. So step 5, which is the estimation of the econometric model. So after the data, when we have data, we can now apply econometric methods, appropriate econometric methods, in order to estimate the intercept and the slope, that is beta 1 and beta 2. So here, let's assume we said now that we have the data, our next task is to estimate the parameters of the consumption function. Example of the estimated economic model is given as this. Let's say we have y, which is consumption equal to 184.08. 184.08, that is intercept. Okay, theoretically, it represents our autonomous consumption plus 0.706, which is our MPC, marginal price to consume, x, which is our y. So beta 1 is equal to 184.08 and beta 2 is equal to 0.706. After we subject our data to after we applied econometric tools to our data, so we were able to estimate beta 1 and beta 2. So the next step is hypothesis testing. As noted earlier, Kinch expected the MPC to be positive, but less than 1. That is to lie between 0 and 1. In our example, we find the MPC to be about 0.71. However, before we could accept this result as confirmation of Keynesian consumption theory, we must inquire whether this estimate is statistically less than 1. Although, as we are seeing it, so it is less than 1, but that is different from statistical significance or statistical testing. So we need to subject it to statistical test to know whether it is statistically less than 1. Such confirmation or refutation of economic theories on the basis of sample evidence is based on a branch of statistics known as hypothesis testing. It's inferential statistics. The next step is to forecast or make prediction. That is, if the chosen model does not refute the hypothesis or theory under consideration, like if our model has passed necessary hypothesis test, we may use it to predict the future values of the dependent variable. Here, in our example here, the future value of consumption, which are our dependent variable, or what's known as forecast variable, y, on the basis of the known or expected future value of expanded variable, or which is also known as predictor variable. In this case, our income. Example, y is equal to 184.04 plus 0.760x. So to illustrate, suppose we want to predict the main consumption expenditure for a future year for which GDP is expected to be $7,269.8 billion. Given the value of the GDP, the mean or average forecast consumption expenditure is about 4,951. That is, if we plug in X is equals to 7,269.8 into that estimated model. So we are going to arrive at $4,959 billion. That is forecast. Lastly, use of the model for control or policy purposes. This is similar to the step we just mentioned. If the estimated model passes all the necessary evaluation tests, the government can manipulate the control variable X, say income, to produce the desired level of target variable Y, say income. I mean, say consumption, rather, not income, say consumption. Here we end lecture 2. See you next lecture. Thank you very much.